In this video, we're mostly going to be discussing Chapter 11, but I'm also going to be discussing a few, important notes to make over Chapters 9, 10, and 11 as we look to wrap up this Intro Statistics course. So, let's take a look now at your formula booklet. This is the formula booklet that you will be allowed to use on your final exam, for example. And it's organized by chapter, and I really like that. But in Chapter 9, this is what it provides you. Everything you see on screen is what you're shown in Chapter 9. And it's very helpful because if you want a particular confidence interval about P, remembering that P is the population proportion, that's going to be P hat, the sample proportion, plus or minus Z subscript alpha over 2, times square root of P hat times 1 minus P hat over N. Okay, very nice that they provide this formula to you. You will have to remember that P hat is the sample proportion and that P is the population proportion, N is your sample size, and so on. And in fact, what is Z subscript alpha over 2? Well, if you didn't practice very much in Chapter 9, then perhaps you've forgotten. But Z subscript alpha over 2 can be calculated like this. So you basically see the alpha over 2 down here, and you take 1 minus that value in the subscript 1 minus alpha over 2. And then where it says QF, that represents the quantile function of the standard normal distribution. So in this previous example, and from a previous video, Z subscript 0.05 is equal to the quantile function evaluated at 0.95. And to find that quantile function in your calculator, we want to then go to second VARS. We're going to go to number 3, which says INV norm. That's where we're going to find the quantile function for the normal distribution. We'll put in 0.95, leave mu as 0 and sigma as 1 for the standard normal distribution, and then that is how you get Z subscript alpha over 2. But notice, while you do have the formula for the confidence interval, nowhere on this formula booklet tells you how to calculate this Z value. So it's on you to remember how to calculate this Z value when it comes to an exam. Then also in Chapter 9 in Section 9.2, we learned about confidence intervals about a population mean. So remember, mu is the population mean, S is the standard deviation of a certain sample, X bar will be the sample mean of that sample, and again we see T with the subscript alpha over 2. So again, your formula chart tells you this formula, so that's nice, but it doesn't tell you what is T subscript alpha over 2. So this is something that you'll have to remember, that when you see T subscript alpha over 2 on your formula chart, that's going to be the T quantile function evaluated at 1 minus alpha over 2. So if you were to see T subscript 0.025, for example, that would be equal to the T distribution quantile function evaluated at 0.975. And to do this, we go to second VARS. We go down to 4, which says INVT, that's the T distribution quantile function. For area, I put in 0.975. And then notice it also asks me for a DF. That stands for degrees of freedom. And degrees of freedom are just our sample size minus 1. And your formula chart tells you this as well, that we compute using N minus 1 degrees of freedom. So we'll just put in 9, pretend our sample size was 10, so our degrees of freedom is 9, and then we click paste, and that's how you figure out that T subscript alpha over 2. Anyways, important to know how to do these because your formula chart tells you where to put that value, but it won't tell you how to find those values. your formula chart also has a little bit of instructions for finding your required sample size to get a certain confidence interval with a certain level of confidence and a certain margin of error. Okay, so that was all for chapter 9. Then we moved on to chapter 10, and so now it's at the bottom of the page because I don't want to reveal chapter 11 yet. But chapter 10 here gives me two test statistics. It tells me that z naught is equal to p hat minus p naught divided by square root of p naught times 1 minus p naught divided by n. And it's nice that they provide this, but that doesn't tell you a whole lot about what's going on. So remember, you are going to have to actually learn a lot of chapters, chapter 10, really all three sections, because your formula chart just isn't very generous with formulas for chapter 10. Now you have the z naught, and that's clearly dealing with the population proportion because you see these p's here. Remember, p hat is the sample proportion, p naught is the boundary between your null and alternative hypotheses, population proportions. Notice that in the denominator, this p naught times 1 minus p naught divided by n, and then you take the square root. If we look back at chapter 8, that is the formula for the standard deviation of the distribution of the sample proportion if your population proportion was that p naught from your null hypothesis. And then t naught, well, that will be your sample mean minus mu naught, which is the mean from your null hypothesis, divided by s, which is your sample standard deviation, divided by square root of your sample size. And this is the t statistic that we're going to use in the t distribution CDF when performing a hypothesis test about a population mean. And so there's two different types of hypothesis tests in chapter 10, one about a population proportion and one about a population mean. And so these have different applications. But I want you to notice more than anything, what is your formula chart leaving out? What part of the procedure do you need to learn about and remember before you come to your exam? And let's see. In chapter 11, the difference is this. In chapter 11, we're going to be learning about hypothesis tests about two population proportions in section 11.1. And then in section 11.2, we're going to talk about hypothesis tests about two population means where we actually have matched pairs data. So this might sound kind of funny to you, but remember all the way back in chapter 1, we talked about how there were two ways where you could set up an experiment. You could either randomly select subjects to belong to your experimental group and randomly select subjects to belong to your control group, or you could actually match up subjects that were most similar to each other among the attributes that you wanted to control for. And once you matched up your subjects, you would split them so that one subject out of the pair would go to the control group and one subject out of the pair would go to the experimental group. Well, you treat, basically you treat your hypothesis test and you can treat confidence intervals a little bit differently whenever you're looking at matched pairs data. Well, so then section 11.3, the last little bit, is about hypothesis tests, about two population means where we have independent sampling, which just means not matched pairs sampling. So another word for matched pairs data would be dependent data. Matched pairs just means dependent. Those are synonyms. And then another way to talk about independent sampling, well, independent sampling is just not matched pairs. So when you're comparing two population proportions, look at 11.1. When you're comparing about two population means, then you're going to look at either 11.2 if it's matched pairs data or 11.3 if it's independent data. Okay, and so the hypothesis testing is actually going to be very, very, very similar to what we did in Chapter 10. So make sure you understand the videos from Chapter 10. Those are important and even, foundational to understanding what we're doing in Chapter 11. But after you understand what's going on in Chapter 10, then Chapter 11 should come very naturally. Also, don't put too much stock into these confidence intervals, where it says, let me highlight it for you. Don't pay way too much attention to these, because I think I'm about to just go ahead and remove these confidence interval type questions from your homework set, and you definitely won't see it on your final exam. But what I really want you to pay attention to instead is the hypothesis testing about two population proportions, then the hypothesis testing about matched pairs data, about the means, about two population means for matched pairs data, and then also the hypothesis testing for two population means with independent samples. So hopefully that makes sense. The parts where I want you to focus, where I don't want you to focus. And again, make sure we've mastered Chapter 10 before we move on to trying to understand Chapter 11. Your homework in Chapter 11 is going to be super critical to us as far as understanding Chapter 11. What I want to point out next is this document that I will be uploading and making available on Canvas. But I put this together a while back, and this is just a guide for the 5 types of hypothesis tests that you'll have to do in this class. So numbers 1 and 2, well, let me just show you what these correspond with. So in section 10.2, we covered hypothesis tests about a population proportion. In 10.3, we talked about hypothesis tests for a population mean. Then in 11.1, you'll see hypothesis tests about two population proportions. 11.2, of course, the test about two population means for matched pairs. And then finally in 11.3, the hypothesis test about two population means for independent samples. So all of these are represented in this little booklet, and it starts off with section 0. And this is just a recap of maybe what you would learn from chapter or section 10.1. And so this is a recap of some of the vocabulary we use, about null hypotheses, alternative hypotheses, what we mean by converses, what we mean by hypothesis testing, what is level of significance, right? And what is a p-value? How do you interpret the p-value as a % confidence? And how do you compare your p-value to your level of significance, which is alpha, in order to determine whether or not you can reject the null hypothesis? So that's just a nice quick little review to read over when you have time. Again, a hypothesis about a population proportion. We've already learned all of this, but there's a quick little one-page summary of how to do this. Number 2, hypothesis about one population mean. We've already learned how to do this in a previous video, but there's a nice one-page summary about how to do this. Number 3, a hypothesis test about two population proportions. This would be new in section 11.1. And so I'll read this out loud because it's important. This test, the test about two population proportions, applies when you want to evaluate the validity of a claim made regarding two populations. So one claim that I might make is that the proportion of Midland College students who live on campus is greater than the proportion of Odessa College students who live on campus, right? So this claim has to do with two different populations, and specifically, this claim has to do with a proportion of individuals in two populations. So that's when this test applies. So we're going to want to write our alternative hypothesis and our null hypothesis in our mathematical symbols. We're going to notice or decide on a specified level of significance, which we're going to call alpha. We're going to calculate the sample proportion p hat for both samples. So it'll be p hat 1 and p hat 2. We'll use the subscript 1 to talk about one of our samples, like Midland College, for example. We'll use subscript 2 to reference the other population, like Odessa College. Then this is how you would calculate the test statistic. Notice that whenever you see the p hat here that doesn't have a subscript 1 or 2, that's actually going to refer to this calculation for p hat, whereas p hat 1 would just be x1 over n1, and p hat 2 would just refer to x2 over n2. So you can calculate your sample statistic. Notice it's a z-naught sample statistic. So that means we're going to use the quantile function that means we'll use the CDF for the standard normal distribution, since we're using a z-naught test statistic. And, after that, things follow just about how it would normally for one population proportion, where you would still interpret the p-value in the same way, and everything else still applies from chapter 10. Okay, so number 4 here in this little guide is talking about a hypothesis test about 2 population means from dependent samples. Remember, dependent means you have matched pairs of individuals where you sent one individual from each pair to a different group. So this test applies when you want to evaluate the validity of a claim made about a mean of 2 populations. So here's an example. Here's an example claim that would regard 2 population means. It says, in identical twins with seasonal allergies, treating the allergies using Zyrtec is more effective in reducing perceived symptoms severity than placebo. And so the neat part about this, and the part that makes this matched pairs, is that we're using identical twins, right? And so you have pairs of twins, pairs of identical twins, and you're saying, well, all of these individuals, all 12 of these individuals, suffer from seasonal allergies. They're paired off as twins in rows, and so this group is going to be my experimental group that receives a Zyrtec treatment. This group over here, this is going to be my control group that receives a placebo treatment. And then we'll have them rate on some kind of numerical scale, probably from like 0 to 10, how much they perceived an improvement in their seasonal allergy symptoms. We will take the mean of both groups, and we want to be able to compare these means using a hypothesis test. But the fact that we have matched pairs of individuals in each of our groups, that will require us to use this type of hypothesis test that is described on this page. So like always, we're going to write our alternative hypothesis and our null hypothesis in clear mathematical terms. We're going to either notice what our level of significance is specified as, or we'll decide on a value for alpha. For each matched pair, we're going to find the difference. And so let's say our data is like this. I'm going to have to draw a little table here to illustrate this to you. So we're going to have the pair number. We're going to have group 1 as a column and group 2 as a column. And so numbering off my pairs of individuals, I have pair 1, 2, 3, 4, 5, 6. I have 6 pairs of identical twins, right? One twin belongs to group 1 and one twin belongs to group 2 from each each pair of twins, right? So let's say among the twins that received Zyrtec, they rated let's say we're rating the amount that their seasonal allergies bothered them or affected them on a scale from 0 to 10. So they might rate this as a 3, a 4, a 3, a 3, 7, and a 2. And then from group 2, the placebo group, maybe they are going to rate their seasonal allergies as affecting them a 5, a 6, a 6, an 8, a 6, and a 5, or something like this. Now, when I tell you to calculate the average difference in the matched pairs, actually, I'm skipping ahead of myself by one paragraph. When I tell you that for each pair of data, find the difference, what I'm saying is let's make another column over here, and I'll just take group 1 minus group 2. So that would be -2, -2 for 4 minus 6. 3 minus 6 is -3. 3 minus 8 is -5. 7 minus 6 is 1. And 2 minus 5 is -3. That's what I mean for each matched pair of data, find the difference, is subtract the two measurements in each pair and make that a separate column. We want to be consistent about subtracting the two data in the same order, so don't do like 3 minus 5 and then 6 minus 4 and then 3 minus 6 and then 8 minus 3, because that's going to screw up your plus or minus signs. It doesn't really matter if you subtract group 2 from group 1 or subtract group 1 from group 2. It only matters that you are very consistent about the way that you do it and you remember how you're doing it. Now, then we want to calculate the average difference in the matched pairs, and so you would want to take a sample mean from this group. So average together -2, -2, -3, -5, 1, and -3. Can do that on the calculator relatively quickly. You go to stat, edit, and then we do -2, oops, that was 0.2, -2, -2, man, okay, sorry. Okay, here we go, -2. Your calculator is very picky about putting in negatives and not minus signs. It will throw a fit if you put in -2. Okay, so there we go. Those are all my differences, and then I'm going to go to stat, and then go to one variable statistics, and that's going to tell me that my sample mean is -2 1/3, or -2.3. Okay. So we just calculated the average difference in the matched pairs, and I call it x bar subscript d to remind myself that that's about the difference. Or, no, never mind. Need to look at my own notes. I'm going to call the average d bar, the average distance. Sorry, the average difference. Okay. Now calculate the standard deviation of the difference in the matched pairs, and we're going to call that s subscript d. And so that's going to be 1.97 according to my calculator. Then we'll calculate this test statistic T0. So we take d bar, which is -2.33, divide by, open parentheses, 1.97 divided by square root of n. N is my sample size. In this case, it was 6. And just so you know, I'm putting in 6. I know that there was 12 individuals total, but there's actually only 6 differences here. So that's important to notice. There's 12 total individuals, but there were only 6 differences. And so this d bar was calculated as an average of 6 measurements, and this s subscript d was calculated from 6. And so in any case, I'm going to use square root of 6 in the denominator here. And this is on your page, so you don't have to forget n is the number of matched pairs. So 12 individuals, but there was only 6 matched pairs. So my T0 test statistic looks like it's negative 2.9. By the way, these parentheses are super important as you're plugging in to your calculator, because you'll get the wrong answer if you don't include the parentheses in the denominator. Now, to calculate the p-value, I consider that the negative absolute value of T0 is still negative 2.9. And where it says CDF, this is going to be the cumulative distribution function of the t distribution, with degrees of freedom is just going to be 5 in my case, because the degrees of freedom is going to be n minus 1. Now, is this a one-tailed test or a two-tailed test? Basically, that's asking, am I... Yeah, I'm trying to prove that this is more effective, not just different than. And so this is going to be a one-tailed test. So let's do the second VARS. I want the CDF for the t distribution, so that's number 6. I'm going to plug in my test statistic, negative 2.9, degrees of freedom 5, and that gives me a p-value of 0.0169. Now, how do I interpret the p-value? I say 1 minus my p-value. Well, that is the times 100%, I should say. This is the percent confidence I have in my alternative hypothesis. So based on this data that we just made up, we could have been 98.3% confident that Zyrtec is effective in reducing seasonal allergies, based on this data if this was the data we collected. It could be 98.3% confident. And the p-value itself represents the probability that you would be making a mistake, or that you would be, making an error in reporting your alternative hypothesis as true. So if you conclude in favor of your alternative hypothesis, if you publish a report that says Zyrtec is effective, there's only a 1.7% chance that we would be making a mistake there. That's what the meaning of the p-value. So again, what you'll have on the midterm is this formula sheet. So you'll be able to see for matched pairs data how to calculate that T0. And it even tells you D bar is the mean and S subscript D is the standard deviation of the differenced data. And what they mean by differenced data is you subtract the matched pairs. So that's important. But notice what your formula chart doesn't give you. Your formula chart does not give you this full page of instructions for how to calculate the hypothesis test. So, print this out and print this guide out and have it ready on your desk for whenever you're doing your online homeworks to practice and prepare for the final exam, but you won't have this on the final exam. So be prepared to do the hypothesis test without it. Let's talk about the shortcut. And so the shortcut here is that we would go to, on your calculator. By the way, before I show you the shortcut, this page says how to use the TI-84. I actually will give you this little packet on your final exam. It'll be in the very back, because I just want you to be able to use your TI-84 and not miss questions because you don't know how to use it. But as we go towards the back, I've got all sorts of hypothesis testing procedures. And so, for example, if we want to perform a hypothesis test about two population means using a data set with dependent samples, and if we already have the statistics, if we already know the average difference in matched pairs and the standard deviation of the differences in matched pairs, we could do this. We could click Stat, highlight Tests. We're going to choose 2, which is t-test, We've done this before in chapter 10, but my mu naught this time is going to be 0, because that's the difference from the null hypothesis. And in our particular null hypothesis with the allergies, we just want to see that there's any difference. So the boundary between the null and the alternative will be 0. In x bar is going to be the mean, or negative 2.333. The standard deviation is going to be 1.97, and my calculator already actually filled this in for me, so that's kind of convenient. I had 6 matched pairs, so n is equal to 6, and this is a one-tailed test, and so let's actually change this to less than mu naught, because my d bar is negative for my one-tailed test. And then I like the draw button. So this is what shows up on your calculator when you click draw. Remember, the highlighted blue area represents your p-value. So I see I have a small p-value. The area under the curve that's not highlighted is representing your confidence in your alternative hypothesis. And this blue curve represents the t distribution. So anyways, it looks like, again, my p-value is really small, but that's what we calculated. And yeah, you know how to calculate the p-value. We've already done it quite a bit. So the last page in this guide, and the last type of hypothesis test you might see, is a hypothesis test about 2 population means from independent samples. So we addressed this in 11.3 in the textbook. In this test applies when you want to evaluate the validity of a claim made about a mean regarding 2 populations. So what if I make the claim that Midland College students on average spend more money on lunch than Odessa College students, right? Maybe the restaurants near Midland College are more expensive than the restaurants near Odessa College student, or whatever, but this is just one claim that you could make about 2 populations. So what you might do is you might take a sample of Midland College students and a sample of Odessa College students, and they're not necessarily going to be a lot of identical twins that attend both campuses. And who knows if identical twins would even really make that much of a difference. Do identical twins usually spend the same amount on lunch? I really don't know. But in any case, high probability that these samples are going to be completely unrelated to each other. They're not going to be matched pairs. And if they're not matched pairs, that's what we call independent samples. So we can calculate our test statistic, which is a t-test statistic, like this. Of course, subscript 1 refers to your first population or your first sample. The subscript 2 refers to your second population or sample. And then you calculate the p-value the same way. We're going to use the cumulative distribution function on our t-naught test statistic. Of course, the negative version of the t-naught test statistic. You do have to know whether you're talking about a one-tailed test or a two-tailed test. And just a little shortcut for you before we end the video is we can go to our little how to use your calculator. And if you want to do a hypothesis test about 2 population means with independent samples, we're going to click Stat. We're going to highlight Tests. We're going to highlight number 2, t-test. We're going to highlight stats. Actually, there's a typo, and I'm glad I used this guide to make this video because there's a big typo. We're not going to highlight 2 tests. We're going to select something else. We're not going to choose 2 t-tests. We're going to go to Stat, we're going to go over to Tests, and we're going to choose, I think, number 4, which is a 2-sample t-test. That's much better. So 4 2-sample t-test. Okay, So then we would put in our x bar 1, which is the sample mean of the first sample, the s sub 1, which is the standard deviation of the first sample, n1, which is the sample size of the first sample. And notice you're allowed to have a different sample size because we're not doing matched pairs data anymore. But you have to plug in all of that. You decide if it's a one-tailed test or a two-tailed test. We're going to say no when it asks if it's pooled. We always say no. And then we're going to click draw. And since I didn't put any data in, it's not going to do anything for us. You would actually have to put an x bar and the standard deviation and the sample size for each of your samples for this to work. But in any case, I'm going to fix this little step number 3, and hopefully this guide and this guide, between the two of them, can really help you with your homework through chapter 11. And let me know if you have any questions through Canvas or through email. Good luck on your homework this week. Good luck reviewing and preparing for your final exam. And I really hope everybody aces this, and I hope you have a great rest of your semester.